Hello students, welcome to the world of chemistry. Today we are going to discuss about P block elements. I have already shared videos on S block, then group P block in group 13, 14 and 15, and now today I am going to share video on oxygen family, that is group 16 element. Now you can see in this periodic table the purple color. So there is this purple color showing the oxygen family, that is group 16. Now which elements are present in group 16? The first is oxygen, followed by sulfur, selenium, tellurium, polonium, and you can see that here in this periodic table oxygen, sulfur, tellurium and polonium, these elements are present in oxygen family. Okay, so they are oxygen family is also called chalcogens. So why they are called chalcogens? So chalcogen means overforming. Most of the metals are present in their oxide and sulfide forms. So we can say that in oxygen family the members are overforming, that's why they are called chalcogens. Now let's see the general properties of this family. Firstly, we will see the general electronic configuration. So the general electronic configuration of oxygen family is Ns2Np4. N is equal to 2, 3, 4, which is the number of period. Now oxygen is diatomic gas. Oxygen is present in gaseous form. Oxygen is present in gaseous form, while the other member, that is sulfur, selenium, tellurium, they are octatomic with ring-like structure. Now oxygen and sulfur, they are non-metallic in nature, while selenium and tellurium, the both are metalloid, which consist both property metal and non-metal. And the last element, that is polonium. So this polonium is poor metal with radioactivity. Okay, so polonium is radioactive element in this family. Now let's talk about reactivity. So oxygen is most reactive element in this family, followed by sulfur, selenium, tellurium and polonium. Then abundance. We know that the 46.6% of earth crust consists oxygen, while 27% volume of atmosphere consists by oxygen. Means we know that the oxygen is most important element for living animals. Also, let's talk about sulfur. Now sulfur, which we called its gandhaka, which is a Sanskrit word. There is old saying that near in Amravati district, near Paratwada, there is a small village called Ashtama Siddhi. Lots of people who are sick, or we can say that the people with some skin problem, or they go to their that place called Ashtama Siddhi. There is a well and they bath in that well. It says that if we bath in that well, our skin problem will get cure in that water. Okay, so this is the old saying. Now why people go there and bath there? Actually in that water, in that well water, if we analysis that water, then the amount of sulfur, there is a more amount of sulfur in that water. Also in volcanic eruption there is a lots of sulfur present in that material. So sulfur, what I am trying to say is the sulfur is from ancient period, it is used to cure skin problem. Okay, so any skin disease or any fungal disease, it is used to cure that skin problem from ancient time in India. Okay, so sulfur is medicine, it has medicinal property. Then selenium, the selenium and tellurium word, these both word are from Greek. The selenium word meaning moon, many moon, and in the tellurium which means earth. Okay, now let's talk about polonium. Polonium discovered by Marie Curie, who is a great lady. She got 2 Nobel Prizes in chemistry and physics. She's she's only lady which got Nobel Prize in chemistry and physics. Okay, so she discovered that element polonium, and one is radium. Now she give that polonium name because it is her hometown. Okay, so polonium is discovered by Marie Curie. It is a radioactive poor metal. Their isotope is naturally occurring isotope is PO 210. Okay, so this is it for oxygen family member. Okay, I hope you will understand that. Now let's move towards the electronic configuration of oxygen family. Now you can see that the family consists oxygen, sulfur, selenium, tellurium and polonium with atomic number 8, 16, 34, 52, 84. Now you can see that the general electronic configuration of this family is NS2NP4. Okay, so this general N is equal to, I already told, the number of period. So for oxygen it is 2, for sulfur it is 3, then for selenium it is 4, tellurium it is 5, and for polonium it is 6. So as we move down the group, principal shell are increasing, that's why the number of N, that is number of period, is also increasing. So you can see that here the for oxygen the electronic configuration is, outer electronic configuration is 2s2 2p4. For sulfur it is 3s2 3p4, then 4s2 4p4 and so on. Now you can see that in their last shell they have 6 electron. Okay, they have 6 electron in their last shell. In p orbital there is a 4 electron present, and to complete their octet or for gain noble gases electronic configuration they need 2 electron. Okay, so while it is better to accept 2 electron for this family. Okay, now let's see some periodic trend or periodic properties for oxygen family. The most important periodic properties are atomic size, ionization energy, electronegativity. So let's see one by one. Firstly we will see the atomic size. You can see in this picture the size of oxygen, sulfur. As we move down the group, we know that in periodic table from left to right in periodic table size decreases, and from up to down size increases. Okay, so why size is increasing? Because as we move down the group, principal shell is added, so that's why size is increasing. Now next property is electronegativity and electron affinity. So in period in oxygen family, down the group you can see that here down the group electronegativity decreases. Okay, so electronegativity decreases, also electron affinity is decreases. So firstly, let's see what is electronegativity. Electronegativity means the tendency of any element to attract electron itself. It is means in electronegativity the element just attract electron towards itself. Okay, and the electron affinity means the amount of energy released when electron added or electron attached to that atom. Okay, means electronegativity means the tendency of atom or the energy of atom to attract electron itself. Okay, and electronegativity means what? The amount of energy released when we add any electron in that particular element or any atom. Okay, so there is a lot difference between electronegativity and electron affinity. Got it? So you can see that after fluorine, oxygen is most electronegative element in periodic table. Now up to down in period means in oxygen family, up to down electronegativity decreases. Remember one thing, atomic size is increasing down the group, the size of atom is increasing down the group. That's why the attraction from nucleus to outermost orbital is less. Okay, so that's why it is easy to remove electron. If the electron is easily removed, then the electronegative character decreases down the group. Okay, and electropositivity increases down the group. We know that oxygen and sulfur, they both are non-metal, then selenium and tellurium are metalloid, and polonium is metallic in nature. So down the group electronegativity decreases and electropositivity increases. Now let's see electron affinity. So what is electron affinity? I have already told you that the electron affinity means amount of energy released whenever we add electron in that atom. Okay, so in case of you can see that in this periodic table, the electron affinity, the order of electron affinity is, firstly it is for sulfur, it is more for sulfur, then for selenium, then oxygen, and oxygen, actually oxygen is almost last. Why this is happening? Okay, so question is why this is happening, why the electron affinity of oxygen is lower as compared to other sulfur, selenium. Okay, so because of small size of oxygen, it is difficult to add electron in oxygen. That's why the electron affinity, the affinity for electron, okay, so for affinity for electron is less in case of oxygen due to its small size, and more in case of sulfur, selenium and tellurium. Okay, got it? This point is clear now? Okay, next point is ionization energy. Ionization energy is also the energy required to release outermost or valence electron. As I told you before, the atomic size, as we move down the group, atomic size is increasing, and atomic size is inversely proportional to ionization energy. If the atomic size is increasing, the attraction between nucleus and outermost orbital, the attraction between nucleus and outermost orbital, it is less in big atom. Okay, so it is easy to remove electron. If the size is large, it is easy to remove electron. If the size is small, then it is hard to remove electron, because there is a more attraction between nucleus and outermost shell. So that's why as we move down the group, ionization energy decreases. Okay, in periodic table, left to right ionization energy increases because left to right atomic size decreases. Okay, but in when we move up to down from oxygen to polonium, the ionization energy increases due to atomic size is increasing. Okay, so ionization energy decreasing due to atomic size is increasing. Okay, remember that. So you can see that here it is saying that ionization energy for group 15, group 15 means nitrogen family, which is before oxygen family. The ionization energy of group 15 is higher as compared to oxygen family. Actually, the ionization energy of oxygen is oxygen family is less as compared to nitrogen family. This is because I discussed this point in nitrogen family in video of nitrogen family. Actually, in case of nitrogen family, you can see that the outer electronic configuration, that is nitrogen. Okay, so for nitrogen it is N2S2 2p3. Okay, so this is the electronic configuration of nitrogen. Now you can see that there is a half filled electronic configuration. Whenever there is half filled and full filled electronic configuration, the that element is more stable as compared to other element. Because of half filled and full filled electronic configuration, the element is most stable than other element. So that's why if the element is stable, it is hard to remove electron from that element. So that's why the ionization energy of group 15 is more as compared to group 16. Now next point is oxidation state. Okay, so if any element or atom donate electron, then it carries positive oxidation state. If any atom accept electron, then it carries negative oxidation state. So in case of oxygen, the most oxygen family, the most common oxidation state is -2. Okay, but sulfur exists in plus, you can see that sulfur exists in +4 and +6 state also. Okay, for selenium, tellurium and polonium, they are present in +2, +4 and +6 oxidation state. The even numbered oxidation state form +6, +4 and +2 to -2, means oxygen family show variable oxidation state. It is even number oxidation state from +6, +4, +2 to -2. The stability of -2 and +6 oxidation state decrease down the group. Okay, so the stability, oxygen, sulfur, they mostly show minus negative state or +2 or -2 negative oxidation state, but as we move down the group, the positive oxidation state, that is +6, +4 or +2, it is increases down the group, where that of plus oxidation state increases. The stability of -2 oxidation state decrease down the group due to increase in atomic size and decreasing electronegativity. So as we move down the group, electronegativity is decreasing. That's why the stability of showing -2 oxidation state is decreased down the group. The stability of +6 oxidation state decreases and +4 oxidation state increases due to inner pair effect. So I have already shared video about inert paired effect or screening effect. Just go there and watch that video, or I will give link of that video in description box. Now oxygen does not show +6 oxidation state due to absence of d orbital. We know that in oxygen family or in chalcogens family, oxygen is first member of family and it does not contain d orbital. It is very small in size. That's why their electron affinity is also low as compared to other element. So it is also does not show positive or +6 oxidation state or +4 oxidation state due to absence of d orbital, while sulfur, selenium, tellurium or polonium, they show +2, +4, +6 oxidation state and they have d orbital. This is for oxidation state. Now next point is allotropes. So what are allotropes? The same element with a different form, we can call that allotrope. Oxygen is present in two allotropic form, that is O2 and O3, that is dioxygen. We know all living organism inhale O2. O2 is or oxygen is a very important part of our living organism. Then ozone, we know that ozone layer. Then the allotrope of sulfur are rhombic, monoclinic, plastic and colloidal. Then for selenium it is rhombic and monoclinic, and also gray selenium is most stable, consists of regular arranged spiral of selenium atom. Okay, then for tellurium, first is non-metallic allotrope and second is metallic allotrope. So the metallic allotrope is more stable. Okay, and for polonium there are two allotrope. First is alpha allotrope and second is beta. Now this is it for oxygen family. I hope you understand all this about oxygen family. I will share next video on group 17, that is halogens. Thank you.